Hi class, today our topic of discussion is congruence of triangle. Now first of all look at the word congruence. Now when are two objects or plane figures said to be congruent to each other? If and only if they have same shape and same size, then only they are known as congruent figures, which means they are mirror image of each other. For example, if I take suppose two line segments, suppose you take AB, this is 5 centimeter, you take another line CD, this is also 5 centimeter, then we can say that the line segment AB is congruent to the line segment CD. Similarly, if I take an angle ABC, another angle PQR, 60 degree each, then I can say that angle ABC is congruent to angle PQR. Similarly, two circles having the same diameter are congruent, or two equilateral triangle having the length of the side same are congruent to each other. Now, we can also say that congruent figures you can superimpose. You can superimpose. Now, what do I mean by superimpose? Now, when you place one object or one plane figure on another, then we say that it coincides precisely with one another. Coincides precisely with one another. So, congruent figures are superimposable. Next, one more thing very important. When we say that two figures are congruent to each other, not only the length of the each side and angles are same, but the corresponding properties or characteristic of the two plane figures are also same, which means properties like area, like diagonal, like perimeter, they will be also same. Now one more thing which is very important, we often get confused with these two things: congruent and similar figures. Now we need to know that congruent figures means same shape plus same size, and similar figure means same shape. If two objects have same shape, then we can say that the two objects are similar. But for congruency, they have to have the same shape as well as the same size, same dimension. For example, look over here, I've taken these two copies. Now these two are mirror image of each other, okay, and they are the same shape and same size, so they are congruent and they are superimposable. See, if I put one over the another, it coincides precisely. So these two figures are congruent to each other. But if I tell you, if I take these two, look over here, these two are similar figures. They both are rectangle, but they are not congruent figures. Clear? So there's a difference between congruent figure and similar figures. Now we look at congruency of triangles. Now let us take an example. Suppose we take two triangles. Suppose I take A, B, C, and I take another triangle P, Q, R, and I tell you AB is equal to side PQ, BC is equal to side QR, and AC is equal to side PR. Angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, then definitely these are having same shape and same size, which means can I tell that triangle ABC is congruent to triangle PQR? And how do we write it? We write it like this, see, triangle ABC congruent. This is a sign for congruency, okay? Triangle PQR. Now look carefully. While writing this statement, okay, the matching of vertices are very important. What do I mean by this? Now, for example, if somebody writes this, triangle ABC is congruent to triangle QPR. Now, that's an incorrect way of writing, because see carefully, the vertices A matches with the vertices P, B matches with Q, and C matches with R. So ABC, if you are writing, you have to write PQR, because that makes the work easier. Because if we write it like this, we know that the side AB is equal to PQ, the side BC is equal to the side QR, side AC is equal to side PR, and angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. So this is an incorrect way of writing. Even if somebody writes triangle ABC is congruent to suppose PRQ, that is also incorrect. Now, for proving that the two triangles are congruent to each other, we need not prove all the 6 things. Okay, that all the 3 sides are equal, all the 3 angles are equal, then only they will be congruent. There are certain criteria. If two triangles fulfill those criteria, then we say that the two triangles are congruent to each other. Now look at those criteria for congruency of triangles. Now look at the criteria for proving that the two triangles are congruent. The first one is side, side, side. If you can show that 3 sides of one triangle is equal to the 3 sides of another triangle, then we say that those two triangles are congruent. If you look over here, AB is equal to PQ, BC is equal to QR, and AC is equal to PR. So we can simply say that triangle ABC is congruent to triangle PQR. Remember, the matching of the vertices is very important. The second criteria, which says side angle side. If two sides of two triangles are equal and the angle which is included between those two sides are equal, then the triangles are congruent. Look over here. Over here I have said AB is equal to PQ, angle B is equal to angle Q, and BC equals to QR. So I can say it implies that triangle ABC is congruent to triangle PQR by side angle side property. Clear? Now look at the third one. This says angle side angle. If two angles of two triangles are equal and the side included between those two angles are equal, then we say that the triangles are congruent. Over here if you look, angle B is equal to angle Q, angle C is equal to angle R, and BC equals to QR. So we can say that triangle ABC is congruent to triangle PQR. Again, the matching of vertices is very important. Look at the fourth one. This is angle angle side, which means in two triangles, if two angles are equal and the corresponding sides are equal, one of the corresponding side rather, then we say that the two triangles are congruent to each other. Which means over here if you see, angle A is equal to angle P, angle B is equal to angle Q, and BC is equal to QR, which means we can say triangle ABC is congruent to triangle PQR by angle side property. Now in the same sum, if suppose PR was equal to BC, then we cannot say that they are congruent. Okay? But over here, BC was equal to QR. The corresponding sides are equal. Hence, they are congruent. Okay? Now this one, number 5th, RHS, right angle. This is right angle. This is hypotenuse. And this is side. RHS is only used when we have two right angle triangle. And if the hypotenuse and any one of the side, over here I have taken BC and QR equal, is equal, then we say that those two triangles, those two right angle triangles are congruent to each other by RHS property. Over here if you look, AC is equal to PR, BC is equal to QR, and they are right angle triangle, hypotenuse and one of the side is equal. So simply we can write triangle ABC is congruent to triangle PQR by RHS property. So these are the 5 criteria to prove that two given triangles are congruent to each other. Now we'll look at some problems from this chapter. Now look at sum number 1. It says that it is given that triangle ABC is congruent to triangle RPQ. Is it true to say that BC equals to QR, and why? Now let us take two triangles. I take ABC. Another triangle I take RPQ, and they are congruent to each other. Now if two triangles are congruent, we know that corresponding part of congruent triangles are equal, which in short is written as CPCT. This is very useful in most of the sum. We are going to use this CPCT. Remember, corresponding part of congruent triangles are equal, which means, can I say AB is equal to RP? AB is equal to RP. BC is equal to PQ. Look, BC is equal to PQ. And AC is equal to RQ. AC is equal to RQ. Which means BC not equal to QR. They are not corresponding sides. They are not corresponding sides. Done. Am I clear? Now look at this sum. In the adjoining figure, AB is equal to AC, AP equals to AQ. Prove that triangle APC is congruent to triangle AQB. Number 2, CP equals to BQ. And number 3, angle APC is equal to AQB. Now first of all, I'll just take out the two triangles they're talking about. See? They're talking about AQB and they're talking about APC. Isn't it? These two triangles we're talking about. Now, in triangle APC and triangle AQB, look carefully. AB is equal to AC, which means for APC I can write AC, and for AQB I can write AB. They're equal. Okay. Then you see AP is equal to AQ. Again, for triangle APC we can write AP is equal to AQ, and these two are given. This is the reason. Okay. Now look carefully. This angle is common in both the triangles, which means angle PAC is equal to angle QAB. This is common. Now look carefully at the figure. Side angle side, which means triangle APC APC, APC is congruent to AQB, is congruent to AQB, triangle AQB, and the reason is side angle side. Okay, the matching of the vertices are very important. You can't write triangle APC is congruent to triangle ABQ. Done. The first part is done. Second part, what they have told, CP is equal to BQ. Definitely CP equals to BQ. Why? Because these two triangles are congruent. So the corresponding part of congruent triangles are equal. Just write CPCT. Done. Now the third part, angle APC, which means this angle, and angle AQB, which means this angle. Of course they are equal because they are corresponding. Angle APC is equal to angle AQB, and the reason will be same, CPCT. Done. Now we look at the next sum. Now look at this sum number 6. In the adjoining figure, ABCD is a quadrilateral in which AD is equal to BC, angle DAB, which means this angle, is equal to angle CBA. Prove that triangle ABD, which means this triangle, and BAC are congruent. Very easy. Look at triangle ABD and triangle BAC. First of all, they have already told AD is equal to BC. This is given to us, isn't it? Then again, angle DAB, angle DAB is equal to angle CBA, given to us. Now if you look at carefully at these two triangles, I'm talking about ADB and triangle ABC. AB is common in both. I can write AB is equal to AB. That's common. Now look carefully. This was equal to this side and this angle was equal to this angle. Which means these two are congruent. Side angle side. We can simply say that triangle ABD is congruent to triangle BAC. And what's the reason? Side angle side. Now once they are congruent, BD has to be equal to AC, which implies BD equals to AC. Why? CPCT, because we know corresponding part of corresponding congruent triangles are equal. And the third one, angle ABD. Similarly, angle ABD will be equal to angle BAC. Why? The same reason, CPCT, corresponding part of congruent triangles are equal. Clear? Now let us look at the next sum. Now look at this sum. Sum number 7. In the adjoining figure ABCD, AB is equal to DC. They have already given AB is equal to DC. And AB is parallel to DC. Prove that AD is equal to BC. Very easy. First of all, they take these two triangles. I'm talking about in triangle ABD and triangle CDB. Look carefully. AB is equal to DC. They have already given. And if you look carefully, DB is common in both. This is given. DB is equal to DB. That's common. Am I clear? And one more thing. This angle and this angle are equal. Why? Because AB is parallel to DC. These two are alternate angles. So can I say angle CDB, first I'll write for ABD. Angle ABD is equal to angle CDB. Why? Because they are alternate angle. which means triangle ABD, if you look carefully, is congruent to triangle CDB. The reason is side angle side, isn't it? And when these two triangles are congruent, we can simply say that AD is equal to BC, CPCT, which means AD is equal to BC, CPCT. Corresponding part of congruent triangles are equal. Am I clear? Now let us look at sum number 9, which says in the adjoining figure, AB is equal to CD, which means this part and this part are equal. CE is equal to BF, they've given, and angle ACE is equal to DBF, they've given already. Okay, we have to prove that triangle ACE, which means this triangle, and triangle DBF are congruent. The first thing you look, AB is equal to CD, they have given. So what I'll do, I'll add BC on both sides. So I can write AB, I can do this, okay? Which means AB plus BC is nothing but AC, and CD plus BC is nothing but DB or BD, whatever. Done. Now we'll prove the first part. Look at triangle ACE and triangle DBF. Okay, we just got AC is equal to DB. AC is equal to DB. Just proved, okay? Okay, then they have already told CE is equal to BF. CE is equal to BF. That's given to us. One more thing is given to us. Angle ACE is equal to angle DBF. This is also given to us, which means if you look at the two triangles carefully, side angle side, which means triangle ACE is congruent to triangle DBF, and the reason is side angle side. Am I clear? And once they are congruent, we can say that AE will be equal to DF CPCT, which implies AE equals to DF CPCT. Done. Now let us look at the next sum. Now look at this sum. Number 10. In the adjoining figure, AB equals to AC and D is the midpoint of BC. Use SSS rule of congruency to show that triangle ABD is congruent to triangle ACD. AD is the bisector of angle A and AD is perpendicular to BC. First of all, D is the midpoint of BC. It means BD is equal to CD. Okay. Now look at the triangle ABD and triangle ACD. AB is equal to AC, already given. AB equals to AC. This is given. Similarly, BD is equal to CD because D is the midpoint, we just got it. BD equals to CD. Why? D is the midpoint. Now look carefully. AD is equal to AD in both the triangle is common. So we can say AD is equal to AD. And that's a common side. Which means, can I say triangle ABD is congruent to triangle ACD. And the reason is side, side, side. Done. Now once they are congruent, the corresponding part will be equal, which means this angle and this angle will be equal, which means, can I say angle BAD is equal to angle CAD. Why? CPCT. And if these two angles are equal, we can say that AD is the bisector of angle A. Done. Now look at the third part. Again, in these two triangles, this angle and this angle has to be equal because they are congruent part. Okay. So angle, can I write angle ADB, angle ADB is equal to angle ADC. Why? CPCT. Suppose I take both the angles as x. So can I say, look carefully, x plus x equals to 180? That's linear pair. Which means, can I say twice x equals to 180? Which means x equals to 90 degree. Which means the line segment AD is perpendicular on BC because these angles are 90 degree. Which implies AD perpendicular on BC. Done. Now look at the next sum. Now look at this sum number 12. It says in the adjoining figure, find the value of x and y. They're given this figure, I'll name it A, B, C, D. And they have already given AB is equal to BC, AD is equal to CD. Okay. Now look carefully. Take triangle in triangle ABD and triangle CBD. If you look carefully, AB is equal to CB, that's already given to us. AD is equal to CD, that is also given to us. And we can say that BD is equal to BD, that's common. Which means, can I write triangle ABD is congruent to triangle CBD, side property. Now once they are congruent, this is again CPCT, which means 2x plus 5 will be equal to 35, which means 2x equals to 30, which means x equals to 15 degree. Done. Keep it till here. In the next video, we'll look at exercise 10.1.